Now we consider returned function values. We're finally getting to the version of functions that you're used to from algebra class. Like, for instance, you probably had a function like this, f of x equals x squared. So if you plug in the input 3, the result is 3 squared, or 9. And we can use these functions in expressions. We could have the sum of two of them, and the first gives us 3 squared, the second gives us 4 squared, or 25 altogether. You should be used to that sort of a mathematical use. Let's see how to do that now in C#. So this is going to be the program return 1. Here is our function f. Of course, it's going to have a parameter. I'll call it x, just like in the mathematical usage before. There's various ways to square a number. The shortest is just to multiply it by itself. So that's what we do here. Now the new syntax is here. To produce a value and send it back to the place where the function was called, we need the keyword return. So we have return and then an expression here that gets evaluated, and its value is returned. Notice another change from our earlier functions. X is an int. X times x is an int. We do not have void here, meaning this is a function that just does something but isn't like a regular mathematical function that produces something. Instead, now we have a type here. This is the type of value produced by this function. If we look at the use of this function, so we go to the main function, we have the line that includes the call for the function f. Notice that this f of 3 is not the whole statement. Functions that return values are syntactically an expression where they are called. This calculates f of the value 3, gets 9, and essentially the 9 is like inserted here in place of f of 3 when it's finally evaluated. We can call again the second line, and again we have embedded function calls here. These function calls are done first to calculate 9 here and 16, and then the sum is done to get 25, and finally the outer function here is to write it to the screen. So this program produces 9 and 25 on the screen. Emphasizing the sequence, it's just sort of like the way you might have simplified things in math class, is we can evaluate one function and then in the larger expression replace the result. Or in the more elaborate one here, we were adding both f of 3 and f of 4. First we'd calculate one function, get 9, and then it's as if we were just executing this statement. And then there's still f of 4, so we need to make another call to f that returns 16, which effectively replaces that position logically as you evaluate it. And then finally we have 9 plus 16, and we end up printing 25. Here I made a very simple function that did nothing but return an expression that corresponds to the way you probably wrote mathematical function definitions before. But in C#, we can have any number of lines ending up with returning something. So here's an example that also illustrates that our parameters do not need to be numbers like in math. Here we can take strings for a first name and a last name and generate a result from them, last name first, and then we return the result. Notice the type of the result. Result is a string, So here, instead of void, which we had for our procedural functions that just did something, this is returning a string result. So we can use this function here in the main program. Again, the function call is embedded in the statement. Effectively, last first is called. So first name becomes Benjamin, last name becomes Franklin, and the result, Franklin, comma, Benjamin, is returned and effectively replaces this call here. So we then write to this console, Franklin, comma, Benjamin. We go on to the next statement. Of course, there's another call to the function embedded. It's going to end up producing Harrington, comma, Andrew, which we would then write to the console. Notice here, unlike our earlier procedural void functions, we are not printing anything in the function here. We are merely returning the string. We then have the flexibility to do whatever we want with the string later. What we choose to do in the program is to write it to the screen. This is unlike the earlier examples where we printed inside the function. You had no choice. The result went to the screen. Let's look at the comparison more here. A more direct comparison is between addition 1 that we discussed before, where we created a sentence in our function. We immediately printed the sentence to the screen, and the function was void. When we called the function, each call to the function was an entire statement line, and there's no extra printing here, well, except for the prompts that are not a part of the function. Compare addition 2. Different name, some problem string, and it returns a string. Again, we create the sentence for the arithmetic statement, but this time we return the sentence. The sentence is a string, we return a string. Nothing is printed. We produced this sentence. The caller here in the main program gets to do whatever you want with the result. What we choose to do here with the string is then to print it to the console. This whole program has the exact same effect as addition 1. After this introduction of functions, here's something to think about, to work on in class perhaps. We talked about painting.cs. In that program, we put all of the code into the one main function. We've now talked about putting a chunk of related code that gets reused, or not necessarily reused completely, but reused except for a change in data, taking that and putting it into a function, and then just calling the function multiple times, not redoing the whole sequence. Go back and look at the painting.cs and see if there are places where we could do something similar, where we could introduce a function that would shorten and simplify the code in the main program.